Okay, this is an optimization problem. It's really just one part of the 1996 AP free response, but I wanted to do the one about optimization. And this one can be done without a calculator, so that's what we'll go ahead and do. We're going to write the area of this rectangle as the base x times the height of e to the negative x squared. We are trying to maximize this area. So we're going to need the first derivative test. So I'm going to take a prime using the product rule. So the derivative of x is 1 times e to the negative x squared plus x times the derivative of e to the negative x squared, which is itself times the derivative of that inside function, the exponent. Derivative there is negative 2x. So I need to set this equal to 0, and it is in my best interest to factor out the e to the negative x squared and be left with 1 minus 2x squared. Now e to the negative x squared is just a decreasing exponential function with a horizontal asymptote on the y-axis, so this term here will never equal 0. So I just need this term to be set to equal 0. So that means I need 1 equal to 2x squared equals 1/2, and x equals 1 over rad 2. And if I do a quick number line analysis, starting where x equals 0 because we're in the first quadrant, labeling that a prime, calling it 1 over rad 2, choose a number below 1 over rad 2 like 1/2, you're going to get 1 minus 2 times 1/4, which is 1 minus 1/2, positive there. Plug in a bigger number like maybe 2, and I'll get 1 minus 2 cubed, definitely negative. So I definitely have a max at the x value 1 over the square root of 2. So the other thing I have to do is prove that this is where the graph of e to the negative x squared has an inflection point. So I'm just going to work with h of x equals negative x squared, and I will take the first derivative, which is negative 2x e to the negative x squared. Then I need the second derivative with the product rule. So negative 2x goes to negative 2, leaving e to the negative x squared, and then leaving negative 2x alone times the derivative of e to the negative x squared, which is itself times the derivative of negative x squared. So I can factor out up here, I'll factor out the e to the negative x squared, which will leave me with negative 2, and then here I have negative 2x times negative 2x, which is plus 4x squared. So once again, for the inflection point, I need to set this second derivative equal to 0. E to the negative x squared will never equal 0. So I really just need 0 equal to negative 2 plus 4x squared, which means 4x squared equals 2, which means x squared equals 1. And in fact, 2x squared equals 1. Coming up here, x squared equals 1/2, and x equals 1 over the square root of 2, just like we thought it would be.